Hello guys, my name is Sarah Kumar Patel. So here me and my teammates are going to present about basic routing information protocol. So first to the introduction. So what is routing information protocol RIP? Routing information protocol RIP is a dynamic routing protocol that uses hop count as a routing metric to find the best path between the source and destination network. It is a distant vector routing protocol that works on network layer of the OSI model. In every network, routing information protocol basically uses port number 520. What is the purpose of RIP? First, we will learn what is hop count. Hop count is the number of routers occurring in between the source and destination network. Main purpose of RIP. The path with the lowest hop count is considered as the best route to reach a network. So here, routing information protocol is the one who prevents routing loops by limiting the number of hops allowed in a path from source and destination. RIP periodically update the network by exchanging packets via these hop counts. So let's see how routing information protocol work from the example. From image, you can see there are total 5 routers A, B, C, source and destination. So here the main goal is to send a packet from source router to destination. For the first time, we have to find out which is the shortest route to take by counting hop counts. From source to A, then A to B and B to destination router counts as 3 hop counts, whereas source to C and C to destination router counts as 2 hop counts. So here packets are being sent from source to C and then C to destination router because it has the lowest hop count rather than other routers. So this is what routing information protocol is used for. So the next part will be presented by my teammate Isa. Thank you.
Limitation of RIP. Although RIP is simple to configure, it suffers from a few limitations. Like RIP is limited to a hoop count of 15. That is, an advertisement can pass through only 16 routers before the route is considered unreachable. Also, RIP is considered slow to recover, which increases the hoop counts and which is not acceptable for RIP when there is change in a network topology. One other problem with RIP, along with slow recovery times, it's possibility of increasing a routing loops, where routing loops are advertisement that send IP traffic through the same series of routers until the maximum hoop counts is reached. Like if the hoop counts is reached to reach up to 15, then the process of RIP will be stopped. So it will be difficult to process it again, or we can say we can connect to another RIP with them in existing network. Basically, RIP does not scale well for use in large networks because of the reasons mentioned over here. Like if the hoop count is limited to 15, then the more large network will not applied. If the recovery is slow, so we can say like if the advertisement is passing through the network and something happened to the RIP, the existing RIP, then to recover that RIP is process is slow, so we can't consider that. Implementation of RIP. For implementation of RIP, Python is used. Python is considered as a convenient tool for the server and networking devices for managing tasks and the configuration. It's simple, easy to learn, and less complex compared to languages like Java or Ruby. All major vendors in the networking domain, including Cisco, started promoting the software configurability of network with Python programming ability, because Python is easy to learn, and we can, if we want to implement something in Python language, it is very easy, and I can say very less cost effective also, because if we are using Python we don't have to hire more programmers to implement it, because one person can easily do that thing with Python. Codes which are used for automating router configuration. First is getPass. To prompt the user for a password without echoing, we are using getPass. Telnet lib. The Telnet lib module provides a Telnet class that implements the Telnet protocol in the router which we are using, or we can say in existing routers. Sys, this module provides access to small objects used or maintained by the interpreter and to functions that interact strongly with the interpreter.
Thank you. Hello. So this is a simple Python code to automate the configuration on the router. And as the library were discussed, we used it explains that the implementation can help with the security, as it asks for the password before the configuration of the router, and keep it safe by entering the configuration mode by using the password. Then it asks for the network IP address. We want to set for the subnet mask as well, and also the host name. So this is shown is only for one router, and the similar can be generated for different routers or different components that we can use in the network, or to make a larger network if in case. And that way we can increase the similar code for the different configurations. Coming on to the network we created, in order to be more accurate, the RIP tends to be a very conservative protocol, and so is the presence of a redundant topology like this one with loops in around to avoid the packets from traveling around. The limit of the maximum cost over here, the hop count for RIPv2 is 15. So for any path in the networks, if it goes to 16, then it is unreachable. Hence, the configuration of RIPv2 is a pretty simple process for a smaller network. Is first enabling the RIP by using the router RIP global configuration command, then instructing the router to use RIP version 2 by typing the version 2 command, then telling the RIP which networks to advertise by using one or more network commands. And with this, the routers can be configured for the RIP version 2. With the network command, you can specify which interfaces will participate in the routing process. The command takes a classful network as a parameter and enables RIP on the corresponding interfaces. Hence, the router 1 and 2 are directly connected subnets. We want to include the subnets in the RIP routing process, right? So to do that, we first need to enable RIP on both routers and then advertise the subnets using the network command. So the configurations for the router 1 and 2 in RIPv2. On router 1, the global configuration mode, enter the router RIP command to enable RIP. Then in the RIP configuration mode, we can change the versions. So remember that the network command takes a classful network number as a parameter, right? So in this case, every interface that has an IP address that begins with 10 will be included in the RIP process. So IP data addresses that begins with 10 are by default the class A addresses and have the default subnet mask of 255.0.0.0. For instance, if any other interface on the router had the IP address of 10.1.0.1, it would be included in the routing process with the network command. You also need to include the link between the two routers in the RIP routing process, right? This is done by adding the another network statement, network 172.16.0.0, or what we have used over here, which we have done here. So you can verify the routers by which has a router R2 directly connected subnet by typing the show IP route command, and we can finalize that this is a working network. And several commands can be used like for configure after the configuration to verify them. Other than show running, you can see more live definitions of how RIP is configured and working by using the IP protocols command. show IP protocols. Simulation panel over here shows us the entire process of the network once the PDU is added. The main responsibility of an routing protocol is to populate the routing table, and so displaying the routing table is a good troubleshooting and verification approach at the end. Routers had directly connected subnets in their routing tables even without a routing protocol. So routers send routing updates out their interfaces to advertise the routes or that this routers already knows. These routers include directly connected routes as well as routers learned from other routers. They listen for routing updates for their neighbors so they can learn new routes, and in this way the metric defines how good the route is. Lower metric routes can consider best route, so less hop count is equals to best route for them. And whenever possible, routers use broadcast or multicast to send the routing updates. So we can see in the simulation panel that RIPv2 is used. The ICMP packets are successfully transferred. Can also be seen in the PDU information. So PDU is a packet datagram unit that we add in the simulation mode of the packet tracer, which we learned in one of the assignments as well. So the Cisco Packet Tracer is a great tool to create these networks, and we can see that the successful transmission of the packet is done throughout the network by using the RIPv2, and the PDU information also shows the OSI layer and the step-by-step process of the entire layer, what on what layer what is happening with the packet, and who is encapsulating the packet, and when it reaches the destination. So at the end there is a successful transmission of the packet on this network. So that's all for group 8. Thank you for listening, and these are the references used for the project.